Hello everyone, my name is James Ryan and I am here to teach you how the basics and eventually a few intermediates of coding, the basics of coding. And specifically, I'm going to be using processing, the language and the environment to teach you guys how to make an abstract visualizer. But small steps first, before we even get to that, I'm teaching you the basics of coding. So, last episode we made our first Hello World program. Just Hello World. We printed it and it outputted to the screen. You can still see it below. It says Hello World. Now we're gonna go back a step. We're gonna get rid of this Hello World for a moment, and we're gonna talk about this episode variables. And I'm not sure if I'll get into the specifics of strings and integers yet, but I will talk about variables. Yeah, I'll go into strings and integers. So let me tell you, okay? Let's create a new, because I probably have to in order to even create a variable. So let's create a new variable called a. Okay, so to do that, you write int a and then write equals. Now, before we get up this far, and then I'm going to write equals 5 and then semicolon. Now, let's take a look at what I've just done, okay? Int a equals 5 semicolon. What have I just done? Let's go through it. The first thing I wrote, int, is a type. What is a type? Well, each variable can be different variables can be different types of variables and can store different types of data. Now, the variable I've chosen here, int, is short for integer. And if you know that, what that means in maths, an integer is basically just means a whole number. So it's 0 or 1 or 2 or 10 or even negative numbers. So even -5, -10, -15. But it's not a fraction, it's not a decimal, it's not irrational or anything like that. It's a whole number. It's just one or more digits, but no points, no decimal points, nothing too fancy. That's what an integer is. The next thing is the name. So this is the variable name I've chosen, a. It's not very fancy, it's not very descriptive. You're probably going to want as descriptive names for your variables and your functions as possible. Now, some good rules for naming your variables is name them what they are. Name them what they store. If you're using a variable to keep track of a score in a video game or something, call it score. If you're using a variable to keep track of the x and y coordinates of an object, call them x and y, or call them coord x and coord y. Something descriptive that tells you what it is. Something important to note when you're naming things in programming, a common convention and a very good one to use, because a lot of things in programming can't include spaces, because spaces are interpreted as, whoa, we're doing a new thing now, we're not talking about the previous thing, by the compiler. If your name of what you call something has multiple words in it, you're going to have to figure out a way to express it in one word. And what programmers usually do is rewrite in something called Camel Case. You know what lowercase is? Lowercase is this. Hello. And uppercase is hello with all big caps. Now normally you write in sentence case, which means you start off with a capital letter, you write the rest of the word in lowercase, then to make a new word, you press space, then you can start a new word in lower caps. It's all lower caps from then on, and then at the end there's a full stop. There you go. But we use in programming something called Camel Case. Camel Case means you start off with a lowercase letter and you write the rest of the word in lowercase. And then whenever you start a new word after that, you begin with a capital letter and then go in lowercase. So that way you can stick the whole thing together. It's all nice and neat, but you can still tell the difference between different words. Hello there, world. So that's how naming conventions work. Now, the next thing is the equal sign. the equals. And the equals doesn't actually mean equals. It's not like algebra, it's not like maths. It's not like saying, well, a equals phi. It's kind of like that, but it kind of isn't. It's, I could say a equals 5, but and it does mean that from then on a equals 5, but it's not saying that it's equal. It's not a mathematical statement. What it's doing is it's setting the variable called a to be equal to 5. It's taking it and making it equal to 5 only at that particular point in the program. The reason variables are called variables, at least in programming, in maths they're called variables because you don't know what they are, so so it could be I don't know why they're called variables in maths actually. Are they called variables in maths? I think they're called something else in maths, but I like to call them variables in maths anyway. Probably because I associate maths and programming and science and all that together. But the variables in a computer program are called variables because they vary. They change over time. They vary. So you could just as easily later on write a equals 10. And then finally you put in a value. And a value is what the variable equals. So for integers, you'd put in an integer, but and so on and so on. And then finally, the semicolon, which says, hey, this is the end of the line, go on to the next one. So let's experiment, okay? Let's say int a equals 5. How do we use this int a? Well, you use this int a. Let's use it using the only function we know how to use so far, the print function. What happens if we put print a? Now you may expect it'll print the letter A, but remember we just set A equal to 5, so what will it print? Let's press run and find out. As expected, it printed 5 down below. If you expected that, congratulations, you're starting to understand. Very good. Okay? Now, what if I go ahead and say, well, int a equals 5, and then I write a equals 10. Now, note that I didn't write int. That's because you only need to declare the type of the variable when you first declare it, when you first initialize it. When you initialize a variable like this, what you're doing is you're basically saying to the computer, hey, I want to make a variable, so go ahead and allocate some storage space in the program storage space for this variable and say, over here we're going to have a nice integer variable called a. Okay? That's what it says. That's what it's saying. And then go ahead and set that value equal to 5. Okay? But after we've gone ahead and created a space for the variable, we don't need to do that anymore. So we just go ahead and say a equals 10. And what a equals 10 basically says is, hey, you remember that place that I created and set aside for a? Yeah, you remember a? Yeah, go ahead and change that a to a 10 now. I don't want it being a 5 anymore. So that's all good. So if I write int a equals 5, and then I write a equals 10, what will print a return? The answer is, of course, 10, because while a starts off being 5, it then goes on to the next line and becomes 10, and then it gets printed. And when it's being printed, it's already been turned into a 10, which means that it'll print 10. Now, what if I go after print a and I write a equals 25? Will this affect it? Will this affect print a? No, it still prints out 10 because it starts off as 5, becomes 10, then when you print a, it prints out 10, then it becomes 25. If I stick another print a after a equals 25, then when I press run, I get 1025. Any guesses as to why? Well, the answer is simply, the answer is that, well, when it got to a equals 5, a was 5, then it got to a equals 10, so a became 10 and it printed 10 out. Then a became 25, and then it printed out 25, but it didn't print out any space or enter in between, so they came out right next to each other and turned into the big number 10. It became 1025 or 1025. And that's how variables work. You initialize them, you can set them equal to things, and you can use them in functions or whatever else you want to do with them. And that's how they work. Another important thing to note is how to make global variables, the difference between global and local variables, and how to make them, and also about initializing variables without evaluating them, without setting them to equal to something. Now I just want to show you something here. If I just write in A and then a semicolon without the equals or the value, then what it will do is it will go ahead and initialize the variable. It will say to the computer, hey, go ahead and find a little memory space and allocate that space to a variable called A. Make this space A. But it won't set it equal to anything. So the computer will say, well, what's this equal to? I don't know, make it null. It'll make it equal to null. And null basically is the computer's way of saying empty. Nothing, there's nothing in here. Not even a zero, not even false. Not even that, it's null. It's not even zilch, it's just nothing. It's neutral, in a way. It's quite an interesting concept to think of. It's void. It's not void. It is. It is void. Is it? I don't know. Never mind. Interesting philosophical concepts to talk about, but this isn't a philosophy class at the moment. What do you mean at the moment? It's not a philosophy class. That can wait for another time, maybe a different series on my channel. Now I want to talk about the difference between global and local variables. Now, local variables, let's say I have int A here, okay? And then I write, and I set it equal to 5, int A equals 5, and then I write print A. Okay, so far so good. I press run, it runs fine. But because I initialized int A within a function, and the function was the setup function, when you initialize a variable within a function, it only exists within that function and only in that particular instance of the function. Here's what I mean. What I mean is if you take when you initialize the variable A, within the function, it initializes it. Okay, it says, okay, set aside memory space for A, and then set it equal to 5. Then you print A, and you print out 5. But then, when it gets to this part here, the end of the setup, it deletes A. It deletes any internal references that you might have put in from there. It deletes any of those variables, and those variables will be lost. It will delete A and allow it to be that space where A once was to be reallocated to some other variable. So if I were to then go into this draw function, which I've told you is definitely called afterwards, is definitely always called in a loop after setup, and I pressed run, I'd get a problem. Cannot find anything named A, and that's because we initialized A afterwards. If I take out this A here, and we get rid of this stuff in setup, and I put initialize A equals 5 here, okay, and then I wrote print A, and pressed play, it will run. And you'll notice first of all that it keeps on printing 5, 5, 5 until it keeps on printing 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, and so on and so on, and it just keeps doing it until I click exit that window to close the program. And that's because draw does in fact run in a loop as pretty much almost as fast as possible. Well, pretty fast. Maybe not as fast as possible, but pretty fast. And it just keeps printing out 5. now I want to talk to you about global variables. So let's go enter down here so we can try and put in some stuff before setup and draw. What if I declare a variable here? Okay, I write int a equals 5. Now what? Well, a global variable is global because it can be accessed from anywhere within the program, and it stays all the time within the program. It is never deleted, and it is only initialized and created once at the beginning of the program, and it then exists with the rest of the program forever until the program is closed. So when I write int a equals 5, I can then write in setup print a, and it will have no problem printing a. I can then go ahead and write print a in draw instead. Print a. Okay? And that will work fine as well. Okay? But I do want you to notice something. Okay? Remember before we had int a in equals 5 in draw, okay? And everything worked fine. If I were to also write int a equals 5 here, we will have a problem. Okay, we won't. Never mind. Ignore that. It's fine. So that's what you need to know. Okay? Variables outside any function are global variables. They are initialized once, and then part of the program from there on. Variables created within a function are initialized during that function, and then can be manipulated and used during that function, but then are destroyed and deleted once the end of that particular execution of the function. So, as an example with the draw function, I can't think of one. Oh well. But the point is that if I were to initialize the first time, initialize a in the draw function, as soon as the draw function loops again, a will have to be reinitialized every time it loops, because it will have to be recalled from scratch. So thank you for watching this video. It's a pretty long one. I might make it 2 parts. On teaching you the basics of how variables work. Thank you for watching. My name is James Ryan, and I have been your host. Peace out.